totally not write down everything she says. Okay, so it's 40 multiple choice questions. So it is across chapters 1, 2, and 3 of your textbook. Chapter 1 and 2 are generally kind of more conceptual. They have the chemical and physical changes in them, classification of matter, a little bit of law conservation of matter, or law conservation mass, however you want to say it, which is just like, you know, matter's not created nor destroyed, it's just rearranged. Like, that's about as simple as I can make that. Whatever mass is present in the beginning is present at the end, it's just the atoms are rearranged. Do you remember that from law of conservation of matter from Friday? Okay, yeah. So that's a lot of the first chapter. Simplification is a little bit there. And experimental scientific method stuff. So like theory versus law is probably the big question that everyone's going to miss. But I'll review that quickly when we go over concept 1. So theory versus law. But the 40 multiple choice questions have a lot of conceptual stuff in it. You know, you're going to be reading and matching it or thinking about vocabulary. I would go back and look at reading guides 1 and 2 because you already did a lot of the work. Just read back through it. But chapter 3 is the math heavy stuff, right? So you will see some peppered throughout there calculations like 2.0 plus 2.5. How many sig figs should be recorded? So I did 2.5 or 2.0 plus 2.5. 2. What? So I said sig figs. Oh wait, 2.
That's dose.
So 4.5, right? But I know that's 4.5. But when you're adding and subtracting, do you do sig figs in your head or decimal? We haven't done so well, right? So 1 decimal, 1 decimal, 1 decimal. That answer is correct, as it is. But if it was 2.51 and you did 4.51, you need to record it to 1 decimal, correct? And that would just be 4.5. So don't forget some of your easy math stuff. Counting sig figs, rounding sig figs, measuring things like if I have a ruler and have a little stick on it and I'm like, measure this, what you always have to do if you have something on the ruler and you're between measurements, between graduations, estimate a further digit. Thank you. So if you have a ruler and you're at 1 centimeter and 2 centimeters, and your little stick has on it, let's call this 10 graduations, and whatever you're measuring goes there, and that's 1, 2, 3, 4, 5. Let's call that right there. Let's call that 1.5. Is that right?
1.50.
Right, you got to estimate 1.50, 1.51, 1.49. I don't know, but it needs to be estimated. Do not leave it hanging. I need that one estimated digit. I think that's going to multiple choice. But I know theory and law, you're going to get mixed up, so make sure you look at that one. And then free response has 8. 1, 2, 3, 4, 5, 6, 7 dimensional analysis problems. When I say dimensional analysis, I mean questions like this from your unit review. So you've seen this on problem set 3B, which I have a lot of stuff passed back. I'll pass that back today. Things like this, you'll have 1 or 2 like simple conversions, 1 or 2 with like a squared or a cube unit, 3 density related ones, which I think these are really close approximate, so I'm trying to do the best I can do from my memory. I don't have a density one on here, but I might say if the density is 2.0 grams per milliliter, and I have a specific volume given to you, find the mass. So I'll ask for the mass or the volume. I'm not going to say solve for the density necessarily. Do we remember the formula for density? Mass divided by volume, right? But remember, we can use density as a conversion factor, like as a fraction. We can flip it any way we want to, depending on what we're looking for. And then you'll have two or three word problems that are similar to like what we are going to see on number 34 right here. This is your unit review. We're working on this towards the end of class. And I'm going to encourage all of us to start on 34, because that's probably the one that you're like, I still don't know how to do the word problems. But you can easily find out through a simple process what you're looking for. So for example, on 34, what's the question? What's the unit of interest? Can you read it? How much water? Now you're like, much. What does much mean? Much means mass, grams. It's looking for grams. You see this given here because it says that you have that much heat released, kilojoules of heat, and this says blah 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 per mole, and that says blah 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 grams per mole. So the per, remember that means conversion factor? It's fraction. So I'll walk us through that, but you will have 2 or 3 like this, so that I want you to be familiar with at least your problem-solving process. All right. So further on for your response. So there's whatever I said, 8 dimensional analysis questions. There's 3 rounding questions. So of course these are written out versus multiple choice. So some similarities between multiple choice and free response, but these are written out versus ABCD. One compare contrast. So you've seen a lot of things in this unit that are like opposites of each other, right? So now tell me something you think was opposite of something else. Oh, hold on, let's go here. Precision and accuracy. Those are like 2 things we could compare and contrast. What else? Theory and law. Maybe what else? Physical and chemical properties or physical and chemical changes, right? One more.
Pure substance and mixture.
Right. So there's all these things that are kind of like easily confused, but we need to be able to distinguish some similarities and some differences between them. There's one question on there, and somebody named it here. What the question is, that you would be comparing and contrasting. You're just writing a simple statement on how they're similar and how they're different. Okay? And there's 2 extra credit questions. Yeah.
Can I share my project?
Yeah. Yes. Everyone should share every, physical or digital. About to say chemical. Physical or digital version of your project with me.
That's
So
Yeah.
I get mine on
Use your words. Google. Share with my apps account. Jessica.inlet@apps.cares.nc.us. Longest email known to man.
is there a picture of a doll?
Yes, picture of Wally. Yep. Yeah. Yeah. If you can email it to me, that'd be great. Yeah. Perfect. Both if you have them both. If you have ability to do both. Okay, so I'm going to switch modes from this whole test thing that's in our head. Let's look at problem set 1 before we look at test. Before we look at our calculator. Problem set 1. Chant with me. I like us to chant our chemistry together. So problem set 1, you should have something so you can work with. So basically you're studying the things you got wrong versus everything under the sun. All right. 1, all I want to know is not true sometimes or always. Ready? 1. Not. Good. 2. Sometimes. 3. Always. 4. Sometimes. 5. Always. Good. 6. Always. 7. Never or not. Great. 8. Mixture.
Sometimes.
8. What else, why would this be sometimes? What else causes smog? It's not like greenhouse gas, but not smog. Smog is very, very specific. That is always true. 8 is always true. Fun fact, nitrogen monoxide or nitrogen oxide. NO is also laughing gas. Who's ever gotten their tonsils taken out? Or wisdom teeth taken out? They give you laughing gas? Huh? They should give you laughing gas. That's a perk of giving you wisdom teeth taken out. Okay. But that's what that's made of as well.
Are you a fan of the laughing gas?
My mom made me sit in the car after I got my wisdom teeth taken out and I fell asleep. And then she made those parties with her. She got me a smoothie or a milkshake. I was just drooling all over myself. And I was like, it's cool. She took pictures and locked it up. Okay. 9. Ooh, okay. This is the one thing that I really hate, that people always think that they can prove everything. Guys, we can't prove anything. There are always exceptions to many, many, many rules and theories. So this is actually, what is this one? 10? I'm going to say never, because a theory can be easily proved. Probably not. A theory is something that's really, really well supported by many, 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 many scientific experiments. If I'm saying many, many, many scientific experiments, do you think that's easy? No, first of all, it's not going to be easy. It's probably going to be hard to support because you have to have lots and lots of repetition in your scientific experiments. And going along with theory, and I'm going to compare that to law in a second, give me an example of a theory that you know of. Scientific theory.
Relativity.
Okay, so theory of relativity, probably many, many experiments on it. I'm going to just go back to one from biology.
Big Bang.
Okay, Big Bang Theory. That's another scientific one that's really going to have quite a bit of controversy about it, and also it's pretty difficult to continue to support because it's really hard to get the antimatter and matter to interact because we can't really get antimatter, period. I'm thinking the theory of natural selection, right? So theory of natural selection. There's all this controversy about it, and there's a lot of scientific experiment that's kind of supported it, but there's also other things that kind of are anomalies. You're like, well, I don't know. Does this fit the theory? I don't know. But theories are really long-winded explanations. Laws, what's the law of gravity?
Stuff falls.
Stuff falls. Point blank. There's no explanation needed. Stuff falls. But theories need to be explained, so that's a big difference between them. So, and also, we generally don't prove things. We have a theory, and everyone works against it to try to disprove it. Because if the point is, if you can find a way to disprove it, then we can kind of evolve our knowledge. But if we can never disprove it, that's kind of what we're going to stick with. But we don't prove it. We just attempt to disprove it. Does that make sense?
Wait, what?
So people do experimentations to try to disprove a theory because they want to continue to support it, but if we find a way to disprove it or to counterbalance some of the evidence, then we're not job as scientists. Okay, 10. What do you guys say? Always, right? Okay. So the only thing that some of you guys might be concerned about is that word explain there. So, but scientific laws state natural phenomena, or they say something about natural phenomena, like for example, the law of gravity, stuff falls. It doesn't necessarily explain in a long-winded term, so if you put sometimes, I understand why you did that. 11. Sometimes. Well-planned experiment will disprove a hypothesis. Sometimes it will. Sometimes it won't. Depends on what's happening here. All right, I'm going to quickly go through a couple of these. 12. Oh, my computer is trying to freeze. Don't do it. Don't freeze. Okay, 12. What do we say?
B.
E as an elephant?
B.
E as an elephant?
B.
12 is E as an elephant. Okay. Cool. 13. A. 14. C. 15. F. 16. B. 17. D. Okay, I see you're erasing. Remember that you're going to go back and look at this for study purposes. At least make sure you know which ones you got wrong because you can study at the same time. Yeah.
What was 16?
16 is B as in boy. 18. 18. What's A?
Physical.
Physical. B. Analytical. C. Inorganic. D. Biochem. E. Organic. Okay, I'll look at the rest of these.
We'll have to see D.
D. Bio. E. Organic. Cool. Okay.
So why
Yeah, go ahead.
would it D be bio? Because it's more related to studying the process of photosynthesis, so it's more
Inside of
chemical.
life. So, because biochem should be, yeah, it's dealing with biology in general, but it's studying something that's inside of life, and plants are life. That's better than sucrose or
That's
another.
more general. That's your point. So that's more
Right.
organic.
Right. Okay, let's switch modes here. So you should have your project, your nanotech project, either pulled up or you have a physical copy of it. Keep your problems at 1 for now, because I wanted to at least give you feedback there. And we're doing a share-a-thon. Okay, so stop talking to your peers for a moment. Share-a-thons are really simple. It's an easy way to kind of get used to presenting a professional narrative here without staying in front and going, here, look at me, look at me. Okay? I remember when I was a shy presenter. Those days are gone. I'm fine to embarrass myself no matter what I need to do. All right, so you're going to be in groups of 2 or 3. Each partner. So if I'm partnering with Sydney and CJ, I'm going to talk for like 2 to 4 minutes, depending on how long-winded I am. Try to stick to the 2 to 3 minute window, just so I can try my best to get this around to many people today. But after I share, he's going to share, I'm going to listen, and Sydney's going to share, and I'm going to listen. And as we are presenting to each other, we're just going to comment a couple times on some paper. You're going to say, CJ was very enthusiastic about. Okay, nanotechnology and dentistry. Make write down some fun facts you learned as you were listening to that person. But this is where the last part of the rubric comes in. It's the engagement piece of your peers. So if he's doing a great job presenting, I'm like, yeah, 10. So the 2 options are, they did a great job or they did a good job. Or no, they did a crappy job. Okay? Good is 5 points. Great is 10 points. So if you're saying they're in between, you got to pick a side. Okay, there is no in between. And that's what I want you to write down from your peers. Couple comments, and then give me a score on good or great. I'm doing the rest of your book, so I'm giving your feedback on about 5 to 10 points worth of their grade, and then I'm gonna make the final call. But other than that, I want that on paper, and then make sure you're sending me the other pieces individually. Any questions right now? I'm gonna put a timer on the board. Name other people with your eyes right now. Groups of 2 to 3. And you can go around the room as needed. Just don't drop the laptops. Pick them up like they're nice people, okay? Don't pick them up off the top. All right, thank you.